Today I want to show you the latest version of our battery simulator. We changed the battery simulator for the Retina models of the MacBook Air to now also accommodate the M1 model. Before, the M1 model needed its own simulator. What we changed is that there is now two positions to solder the connector onto. The left side is for the MacBook Air Retinas with Intel processor, the A1932 and the A2179. On the right hand side there's space to solder the cable or the connector for a A2337, i.e. the M1 model of MacBook Air. Both connectors can be soldered at the same time, but obviously you can only use one at the same time. Also, we have been struggling with the name of this product. We started out by calling it a battery port tester, which people failed to understand what that meant. Then we called it the known good battery because it can be used as a known good battery, but even that seems to be confusing people. I hear my customers calling it a battery simulator, so now we called it a battery simulator. We hope that will make things clearer in the future. When we sell the board, it comes like this with no connectors mounted. You yourself will have to harvest the connector off an old dead battery and solder it in place like I did here. When soldering the cables, they have to go in exactly the same order as they are on the connector. Same story for the M1. The connectors actually have the same pinout, except they are in reverse. Apple wouldn't be Apple if they didn't set some sort of booby trap. When connecting to a MacBook Air motherboard, you can connect this board to the power supply. Here in the corner it says you should put 13 volts. The plug to do that is shipped with the battery simulator, but you have to solder your own cable to attach it to the power supply. You obviously set your power supply to the voltage listed, in this case 13 volts, and you can plug it into the power supply. Now let's try the battery simulator on a motherboard. We connect it to the battery port. And on the other side I have two USB-C testers connected so that we can see if the machine switches on or not. Let's see what it does. We turn on the power supply. So the blue blinking indicates that the SMC in the computer is running. The ISL LED shows that the charging chip, the ISL chip, is working, or at least talking to the battery simulator. And the PP3V3G3 hot is alive, and it's managing to talk to the PMIC. The PMIC connects to the same I2C bus as the charging chip. Why, I have no idea. The Mac itself doesn't seem to be using this connection, but it does enable our battery simulator to say hello to the PMIC, and if it answers, then this LED comes on. Not all models of the MacBook Air work this way, but this one does. So this shows us that the PMIC at least is not dead. It might not be putting out all the voltages that it should, but it's talking to the battery simulator. The three charging LEDs show that the battery is being charged, but in this case there's no battery and it's not really being charged. It is just the voltage from the power supply that is lighting up those LEDs. The other way to use the battery simulator is to not connect the battery simulator to the power supply, but to connect the Mac to a power supply. In this case I'm using a Dell dock, a WD-15. Those are second-hand. They're a lot cheaper than the real authentic Apple power supplies, and yet they function like a good quality, decent USB-C charger. And as an extra bonus, you get a zillion ports for free. But in this case, we're just using it as a normal charger. So we're going to plug it into the board. I have the Chipmunk USB-C monitor connected so we can see what's happening with the voltages. Let's plug it in and see what happens. So you see the power supply comes on at 5 volts, as indicated by the green light. It very briefly switches up to 20 volts and then immediately turns off. We see the same behavior on the battery simulator. The lights come on briefly, but it goes off. The battery simulator is not really managing to run because it needs its power from the charging of the Mac. But at least we can see that the Mac very, very briefly tries to charge the battery and the battery simulator comes on. But then when the Mac switches off, so does the battery simulator. So it doesn't really give us a chance to tell us anything useful. Now we'll do the same experiments with another machine. This one is still in the chassis. The battery is disconnected. We plug it into the charger again. Green, 5 volts, and the machine switches off. It doesn't switch up to 20 volts, and it even switches off. Let's now connect the battery simulator. Plug it into the power supply. Still set to 13 volts. Let's turn on the power supply. Let's see what happens now. So the SMC is running. The ISL chip is active. So at least the problems from before are not caused by a dead ISL chip. And even the PMIC is running, so everything looks good on this side. Let's turn it on and see what happens. It seems to be working. It's a bit angry, but that's okay. And it's booting. So the Mac seems to be working just fine. So in this way we can see and show that the problem with this machine is solely the charging circuit. Probably the CD32 something or another that is not working fine, but the computer part of the computer is working just fine. So now with the battery simulator connected, we have effectively a fully charged battery that will never run out. So we could even use the computer in this way, but it wouldn't be very portable. But at least we know that if we repair the charging circuit or the USB-C circuit, then we'll have a working machine, because the machine itself, the computer part of the machine, is working. If you like this video, then please subscribe to our channel. We make lots and lots of different products that make life for the repair technician a little bit easier. Thank you for watching. Please visit our website www.cmizapper.com.